The electric vehicle revolution has been unstoppable up until now. China, the world's biggest car market and EV producer, might be about to change everything. Whispers are swirling about a new breakthrough so disruptive that even Tesla's own Elon Musk is reportedly paying close attention. It's good to see electric vehicles making progress in China. Some say it could make electric cars obsolete overnight. Others believe it could shake the entire auto industry to its core. But what exactly is this new technology? And could it really end the EV era before it even reaches its peak? Let's find out. In a stunning announcement that has sent shockwaves through the automotive world, China claims to be on the verge of unveiling an engine technology so revolutionary that it could render electric vehicles obsolete. This bold assertion comes with the endorsement of China's highest office, with the president himself suggesting this innovation has the potential to completely upend the EV industry's rapid global expansion. But is this truly the transportation breakthrough of the century? Or simply another grandiose claim in the increasingly competitive global automotive market? Before discovering what this mysterious new engine actually is and whether it lives up to its revolutionary promise, we need to examine the full context of how transportation technology reached this climactic moment. For more than a century, the internal combustion engine has ruled the world. From the earliest automobiles to modern-day supercars, ICE technology has been at the core of transportation, powering everything from family sedans to commercial trucks, airplanes, and ships. But while the ICE has long been seen as the pinnacle of automotive engineering, its reign is now facing an undeniable decline. With increasing environmental regulations, rising fuel costs, and growing interest in alternative power sources, the world is shifting away from gasoline and diesel engines. China, a nation that played a significant role in the mass production and modernization of ICE, is now looking beyond them, leading the world into a new era of engine technology. To understand the significance of internal combustion engines, we need to go back to the late 19th century. The first commercially viable automobiles, such as the Benz patent motor wagon in 1885, were powered by small gasoline engines. These early machines revolutionized personal transportation, making travel faster and more accessible than ever before. By the early 20th century, car manufacturers like Ford, with its groundbreaking assembly line, made gasoline-powered vehicles affordable for the masses. As cars became more prevalent, so did gasoline and diesel engines. Throughout the 20th century, innovations in engine design, fuel efficiency, and mechanical reliability led to the mass adoption of vehicles. The world built vast infrastructures around these engines: gas stations, oil refineries, highways, and manufacturing plants. Gasoline and diesel engines powered entire industries, from agriculture to logistics, ensuring their dominance in global transportation. But while internal combustion engines offered power and convenience, they also came with drawbacks, ones that would eventually lead to their decline. These engines are incredibly effective at converting fuel into motion. However, their efficiency comes at a cost: pollution. The burning of fossil fuels releases harmful emissions such as carbon dioxide, better known as CO2, nitrogen oxides, and particulate matter, all of which contribute to air pollution and climate change. Throughout the late 20th century, governments and environmental agencies began imposing stricter regulations to curb pollution. The introduction of catalytic converters in the 1970s helped reduce toxic emissions, but even with advancements like fuel injection and turbocharging, internal combustion engines still remained major contributors to global carbon dioxide emissions. Another problem with traditional engines is energy efficiency. Traditional gasoline engines convert only about 20 to 30% of the energy from fuel into usable power, with the rest lost as heat. Diesel engines fare slightly better, reaching efficiencies of around 40%, but they come with their own set of environmental concerns such as nitrogen oxide emissions. With rising awareness of climate change and the push for cleaner energy solutions, it became clear that internal combustion engines in their traditional form were not a sustainable long-term solution. As environmental concerns grew, governments worldwide began enacting stricter emissions regulations. The European Union, for instance, has implemented increasingly rigorous carbon dioxide emission limits, pushing automakers to develop cleaner engines. The United States, China, and other major automotive markets have also introduced stringent fuel economy and emission standards. One of the most significant moves against internal combustion engines came in the form of bans and phase-out plans. Several countries, including the United Kingdom and others, have announced timelines to phase out the sale of new petrol and diesel cars, aiming for a future dominated by electric and alternative fuel vehicles. China, the world's largest auto market, has also signaled its intention to phase out traditional fuel-powered vehicles, though a specific timeline remains uncertain. For automakers, these regulations have made it increasingly difficult to rely solely on internal combustion engines. The need for lower emissions and higher efficiency has led to the development of hybrid powertrains, turbocharged small displacement engines, and even alternative fuel technologies. However, none of these solutions fully resolve the core issue. Internal combustion engines are still fundamentally reliant on burning fossil fuels. While Western countries pioneered the development of internal combustion engines, China played a crucial role in their mass production and modernization over the past few decades. China has been producing and using more vehicles than any other nation. While Chinese automakers have invested heavily in technology, refining engines to be more fuel-efficient and environmentally friendly, China's auto industry undoubtedly benefited from technology transfers, joint ventures with foreign automakers, and government policies that encourage domestic innovation. Companies like Geely, BYD, and Great Wall Motors have developed advanced and hybrid powertrains, some of which rival those from European and Japanese manufacturers. However, China has also recognized the limitations of internal combustion engine technology. The country's dependence on oil imports poses a strategic vulnerability, and its major cities suffer from severe air pollution. As a result, the Chinese government has aggressively promoted new energy vehicles, or NEVs for short, including electric and hydrogen-powered cars. But what if there was another way? Despite ongoing advancements in ICE technology, the writing is on. With increasing government restrictions and public demand for cleaner vehicles, internal combustion engines are steadily losing ground. But while internal combustion engines have problems, the shift to electric vehicles hasn't been as smooth as many expected. For years, electric vehicles were marketed as the inevitable future of transportation, cleaner, more efficient, and more advanced than their gasoline-powered counterparts. They were supposed to end our dependence on fossil fuels and eliminate the environmental damage caused by traditional engines. And for a while, it seemed like that future was finally arriving. The electric vehicle industry exploded in popularity. Car manufacturers scrambled to shift production away from internal combustion engines, and governments around the world poured billions of dollars into subsidies to make electric vehicles more accessible. But beneath the surface, cracks in this revolution have started to show. Rising costs, failing infrastructure, and the environmental consequences of battery production have all raised serious concerns about whether electric vehicles can truly replace traditional cars at scale. Meanwhile, as the rest of the world remains focused on electrification, China has been quietly developing something entirely different, an engine so advanced that it could make both gasoline and electric cars obsolete. But for now, let's take a closer look at how EVs rose to dominance, and why they may not be the perfect solution everyone hoped for. The modern EV revolution began with Tesla. Before the company disrupted the industry, electric cars were seen as slow, impractical, and suitable only for niche markets. They had poor range, took too long to charge, and weren't taken seriously by most major car manufacturers. That changed in 2012 with the launch of the Tesla Model S. It was fast, luxurious, and capable of traveling over 300 miles on a single charge, proving for the first time that EVs could be as good as, if not better than, gasoline cars. This breakthrough sparked an industry-wide shift. Suddenly, every major automaker wanted to get in on the EV market. Companies like Ford, General Motors, and Volkswagen started pouring billions into developing their own electric models, fearing that if they didn't adapt, they'd be left behind. Meanwhile, governments worldwide introduced aggressive policies to phase out gasoline-powered cars in favor of electric alternatives, setting ambitious deadlines for achieving full electrification. The results were immediate. EV sales skyrocketed. In 2020 alone, despite the economic downturn caused by the global pandemic, electric vehicle sales increased by 43% worldwide. By 2023, 1 in 5 new cars sold in China was electric, and EV adoption in Europe and North America was also on the rise. It seemed like the future of transportation had finally arrived. But as adoption increased, so did the problems that many had overlooked in the rush toward electrification. While Tesla may have ignited the EV boom, it didn't take long for China to take control of the industry. The Chinese government saw electrification as an opportunity to reduce its dependence on foreign oil and establish itself as a global leader in automotive technology. In a few short years, Chinese EV manufacturers like BYD Neo Xpeng and Li Auto surged to the forefront, producing millions of electric cars and dominating global markets. BYD in particular emerged as a serious contender, surpassing Tesla in total EV production in some quarters. Unlike Western automakers, which relied heavily on third-party battery suppliers, Chinese companies invested heavily in battery technology, giving them greater control over production costs. But there was a catch. China's dominance in the EV market wasn't purely the result of technological innovation. A significant portion of its success was due to massive government subsidies. Billions of dollars were poured into the industry, making EVs artificially affordable and incentivizing companies